So we're asked to graph the following functions: absolute value of x given that domain and 2x plus 3 given that domain. And we're asked to find these three function values: f of -5, f of 0, and f of 2. So I'm going to graph these and see what we come up with. Well, now I know the absolute value of x is going to make a v that touches right here at 0. Here's the problem, folks. The problem is this is a piecewise function which has a domain restriction. The domain restriction says x cannot be less than 2. So basically it says that x is 2 or larger. So what I do is I graph the absolute value of x. And the absolute value of x is always going to be a slope of 1 in both directions. Slope of -1 in the left side and a slope of +1 on the right side. And it's always going to be a v. Okay? With a vertex at 0, 0. Okay? So I graph this absolute value of x function. And then I come in with an eraser and say, okay, where is x equals 2? X equals 2 is right here. So I make a point there. Everything to the right of that point stays, and everything to the left of that point has to go. So I come in with my eraser and I erase, and you can kind of still see where I drew, but basically everything to the left of that point has to go because it's not part of the domain of this function. Okay, now graph this line. It says 2x plus 3. Alright, so we start at +3, 1, 2, 3, and we go up 2 and over 1. Up 2 and over 1. Now what? Draw a straight line. So I take my ruler and I line up my 3 points, and I take my pencil and I draw my nice, neat, straight line. And I say, okay, well, there's my function, right? Well, again, no, because this says x has to be what? Less than or equal to 1. So I go to that point, x equals 1, and I come up, and there's the point. Everything to the right of that has to be erased. So I come in with my eraser and I erase everything to the right of that point. Okay, because it says less than 1. So now here is my piecewise defined function. That goes that way and that goes that way. Okay? So that's how we graph these. You basically graph these functions, and then if it says less than, you erase everything to the right. You keep everything to the left and you erase everything to the right. If it says greater than, you keep everything to the right and you erase everything to the left. Okay? So that's real simple, real easy. There's our picture. Now, below, we're also asked to find f of -5, f of 0, and f of 2. We have a couple of options here, folks. One option, of course, is that we could take these and look at our graphs. Okay? So let's look at that. F of -5. What does that mean? That means go to x equals -5. 1, 2, 3, 4, 5. And if I do that and I come down 1, 2, 3, 4, 5, 6, 7, it looks like it should cross at about -8. But I'm not sure. Maybe my graph's not so great. Another way I could do this is ask myself, which domain does -5 fall in? And the answer is this one, which means I use this equation. What's 2 times -5? -10. What's -10 plus 3? -7. So the answer has to be -7. And if you have a very neat graph, you can read that right off of the graph. Okay? Sometimes my graphs aren't as neat as I hope they would be. How about f of 0? Again, which domain does 0 fall in? Well, 0 is less than 1. So we're going to pick this line, or this function. Well, 2 times 0 is 0. 0 plus 3 is 3. Okay? Or we could try it here. What is x equals 0? It's right here. Go up 1, 2, ta-da, 3. So either way, with the graph or with the equation, the answer is 3. How about f of 2? Well, this is less than or equal to 1. This is greater than or equal to 2. So f of 2 falls in this domain, which means you plug it into this function. So you plug 2 here. What is the absolute value of 2? The absolute value of 2 is 2. And that's how you find these function values. If you have any questions, please come see me.